So today we're going to talk about the natural logarithm. So if you remember, the natural number was e. So a natural logarithm is a log with base e, the natural number. But we do note it a little bit of a different way. So you might expect it to look like this. Like, oh, there's the natural log. But because it's called natural log when it has the natural number, they don't write it like log base e. Instead, natural log, the letters L, N, and L, but they use them in this order, L and N. So that means natural log. It means the same thing as log base e. Okay? So you can see that here from your text. So we can do all the same things we could do before. We can solve. We've already seen how to graph. We can use the properties as before because it's a logarithm just like everything else. Just get used to the notation. So here is the natural log. We have two terms. I'm going to combine them together, but before we do that, we're going to use the power property to condense them each into their own logarithm. And then with the subtraction sign, that's going to be the quotient property. So I have the natural log of 8 over x cubed. Excuse me. All right, same idea here. I'm going to change this to the natural log of 3 squared plus 8. And then I'm going to use the product property because it's adding. And 9 times 8 would be 72. So I would get the natural log of 72. And then same idea here in this last example. Natural log of x to the 20th plus the natural log of y to the 5th minus the natural log of z squared. So here, this would be the natural log of x to the 20th times y to the 5th. And then when we combine those together, we'd get the natural log x to the 20th, y to the 5th over z squared. Just like before. Okay, so basically we're reviewing the things of before just with a different base. All right, so here if we want to solve each equation, so the first equation is a log equation with only one logarithm in it, and the x is in the logarithm, so if I want to get the x out of the logarithm, I would want to rewrite it in exponential form. So the base is e. Okay, remember, you don't see it there, but it's there. And then the exponent's 5, and that should equal x. So basically, rewriting it solved it here, and if you put e to the 5th in your calculator, you should get that x is equal to 148.4. For the second equation up here, same setup. Okay, it's just going to be a couple more steps because there's more stuff inside the logarithm. So this would be rewritten as e to the 3rd equals 6x plus 1. Okay. I would want to subtract 1 from each side. So I would have e to the 3rd minus 1 equals 6x. And then I'd want to divide by 6. So I would have x equals e to the 3rd minus 1 all over 6. If there was no calculator, I would leave my answer like that. With a calculator, I should be able to calculate that x is equal to 3.18. All right, so last one here. Okay. I'm going to go ahead and again rewrite. So I'd have e to the 6th equals 2x plus 1 squared. To get rid of the squared, I'm going to square root both sides. And that's going to give me 2x plus 1 equals plus or minus e to the 3rd. And then I would subtract 1 from both sides. So I'd have negative 1 plus or minus e to the 3rd equals 2x, and divide by 2. So x is equal to negative 1 plus or minus e to the 3rd over 2. If we put that in the calculator, we get 9.54 and negative 10.54. And these are log equations, so we should be checking each and every one of these answers and making sure that in the original equation, they don't make something that is undefined when we plug them in. Okay? In this case, they all work, but you definitely want to be checking. In the next example, you see e show up as something where it's an exponential equation. So remember, if we wanted to take an exponential or solve an exponential equation, and we could not rewrite both sides with the same base, we wanted to use log. You can use any log you want. We used common log because it's base 10, it's our number system, there's a button for it on the calculator, okay, these kinds of things. But now that e is the base, I'm going to choose to use natural log, and I'll show you guys why. If I do that here, it just kind of saves me one step. And that's right here. Remember we talked about before, if I had log base 2 of 2 to the 5th, that's like asking me 2 to what power is 2 to the 5th? Well, it must be 5. Okay, so basically when the base here and the base here match, you have the exponent. So here you have log base e of e to the x plus 3. So it's just going to be x plus 3 equals the natural log of 24. So then x will equal the natural log of 24 minus 3. Notice the minus 3 is not in parentheses as part of something that's in the natural log. If you do this correctly, you should get 0.18. So for the next equation, I would divide both sides by 5. So I'd have e to the negative 3x equals 9. I would take the natural log of both sides. And then I would have negative 3x equals the natural log of 9. And I would divide both sides by negative 3. And in the calculator, when you do that, you should get negative 0.73. Again, our test will most likely be no calculator. So you would just leave answers in this form of x equals natural log of 9 over negative 3, and that would be fine. Same idea here. We want to isolate the e to the 5x. So the first thing I would do is I would add 8 to both sides. And then I would divide by 2. And then I would take the natural log of both sides. So I'd have 5x equals the natural log of 19. I would divide both sides by 5. Without a calculator, my answer is x equals the natural log of 19 all over 5. If I plug that into the calculator, I should get 0.59. Right, and then we have one other small application problem. You know, there's a lot of science applications with logs and exponents, so the problems we're looking at, we don't always know the background of the science. You guys should be using logs and stuff in chemistry. But if they give us the formula, we should be able to decipher the information. So don't be afraid of the information that's there. Just try and read it and understand what exactly it is that they're giving you. So it says carbon dating is a method used to determine the age of organic material less than 50,000 years old. One of the formulas for carbon-14 dating is this crazy-looking thing. And then it tells me NF over NO is the percent of carbon-14 remaining, and T is the time in years. So then they tell me a fossil is found to have 30% carbon-14 compared to a living sample. Using the formula, what is the age of the fossil? Okay, so T equals the natural log of, and remember they said this was to represent the percent remaining, and everything else here is a number. So T is what I'm looking for, because I'm looking for the age of the fossil, so how old it is, how many years it's been there. And then NF over NO, they said, is the percent, and they told me it has 30%. So I'm really just looking to do this calculation. Okay, but I just kind of had to wade through that information to understand that. So if we do this calculation correctly in our calculator, we should get 9,902.8 years old.